Hello, today we're going to go over 6-4 log rules, using logarithmic properties to simplify expressions. Check the description below to see a quizzes link that goes with these questions. Number 1 says to condense 4 log 2 of 3. Now, to do this one, you want to use the power rule. And the logarithmic power rule is r log b of x equals log b x to the rth power. So if we apply that, we have log 2 of 3 to the 4th power. You can also write that as log 2 of 81. This would be your condensed expression. Okay, number 2, condense 4 log 8(3) minus log 8(4). So you want to use the power rule like before, and we'll rewrite it for the first time. So we have log 8 of 3 to the 4th power, and then minus log 8 of 6. Now, we're subtracting two logs that have the same base. Because they have the same base, we could do the subtracting logarithms property. Log b of x minus log b of y equals log b of x over y. And 3 to the 4th from the previous example is 81. So we have log 8 of 81 divided by 6. And you can reduce this fraction by divide each by 3. The unity fraction 3 over 3. So our simplified condensed expression is log 8 of 27 over 2. For the next one, it says condense log 2 of 225 minus log 2 of 5 plus log 2 of 3. So with these two, we'll use that property where we subtract the logarithms. So we can rewrite this as log base 2 of 225 divided by 5. And then plus log 2 of 3. So 225 divided by 5 is 45. So we're adding two logarithms together. The property we can use, since we have the same bases, is the adding logarithms property. Log b of x plus log b of y equals log b of x times y. So we can rewrite this as log base 2 of 45 times 3. And if you were to multiply that out, you get log base 2 of 135. Number 4, if log 3 of 6 plus log 3 of 7 equals log 3 of n, what is n? So we're adding the logarithms together, so you're going to multiply the 6 and the 7, the two arguments, so it'd be log 3 of 6 times 7. That's going to equal log base 3 of 42. So n equals 42 in this case. On number 5, we have ln e to the 2nd power plus ln e to the 5th power. The first thing you want to do is use your power rule from before. So move those exponents to the front. We have 2 ln of e plus 5 ln of e. Now ln of e is basically log base e of e. And you'll use that property to say that it's 1. If you have a log with a base that's the same thing as the argument, that would equal 1, as long as the base is not 0 or a negative number or 1 or something. So instead of L and E, we can replace those with 1s. So we have 2 plus 5, 7. Number 6. If log 5 of 54 minus 3 log 5 of 3 equals log 3 of n, what is n? Okay, let's first use the power rule to move this 3 as an exponent. So we have log 5 of 54 minus log 5 of 3 to the third power, which is 27. And then we have two logarithms that are subtracted. They have the same base, so we could go ahead and use that property. So then we have log 5 of 54 divided by 27. That's the same thing as log 5 of 2. So n would equal 2. Number 7, if log 7 of 64 minus log 7 of 4 plus log 7 of 5 equals log 7 of n, what is n? So first we're subtracting these two logs. Another way you could think of this property is to rewrite this negative 1 put in the exponent. So we could think of it as log 7 of 64 plus log 7 of 4 to the negative 1 power. Remember, negative 1 power is the same thing as flipping the fraction, changing the exponent to a positive. So it'd be 1/4 here. And if you were to multiply 64 times 1/4, that's the same thing as 64 divided by 4. So we would rewrite it again as log 7 of 64 divided by 4 plus log 7 of 5. Okay, 64 divided by 4 is 16. So we have log 7 of 16 plus log 7 of 5. We're adding the logarithms with the same base, so we can multiply the two arguments together. 16 times 5. So then we have log 7, 16 times 5, and that would equal log 7 of 80. So n would equal 80 in this case. On number 8, it says 7 log 5 of 25. Well, you could think of 5 and the 25 log 5 of 25 as 5 to some power equals 25. Using the inverse property here. If log b of x equals y, then b to the y equals x. So basically, again, if log 5 of 25 equals something, then 5 to that something power equals 25. We know that 5 squared equals 25, so that means that this is really 2. So 7 times 2, 14, would be your simplified expression. Number 10, condense. Log 13 of 121 divided by log 13 of 11. By looking at this, it looks like it's already simplified, but if you look at it closely, it has the form that you could use as a change in base. So we start with the changed base, and we want to turn it into a single logarithm. So instead of having that 13, we could just have log 11 of 121. And that's the same thing as say 11 to some power is 121. That would be 2. Number 11, condense 2 log x plus 3 log y. Use your power rule to move these to the exponents. So we have log x to the second power plus log y to the third power. We're adding two logarithms together with the same base of 10, so we're going to multiply those together. Log x squared y cubed. Condense log k of x minus 2 log k of y plus 3 log k of z. So we are going to first use the power rule. And rewrite it. Log k of x minus log k of y to the second power plus log k of z cubed. We're subtracting these, so we're going to divide the two arguments. Log k of x divided by y squared plus log k of z cubed. From there, we're adding these two, so you're going to multiply this by the numerator, basically. So we're going to rewrite it, and we have log base k of x z cubed divided by y squared. And that would be our condensed expression. 13. If log 3 of 72 minus log 3 of 8 equals log 3 of n, what's that n? We're subtracting the logs. They have the same base, so we're going to divide 72 divided by 8. And that will be log 3 of 9. 3 to the second power is 9, so your answer is 2. Condense log 6 of 6z minus 2 log 6 of z over 2. Use that power rule. We could put the whole negative 2 in there. So we have log 6 of 6z minus, or let's just say plus, log 6 of 2 over z to the second power. And again, we just flip the fraction, change this to a positive exponent. So we'll multiply these together. We have log 6 of 6z times 2 squared, which is 4, over z squared. One of the z's cancels, and then we have 6 times 4, 24 over z. And this would be our simplified expression. Alright, on number 15 it says condense 2 log 99 of 8 divided by log 99 of 4. It looks like another one of those that we could use the change in base formula. First, let's go ahead and use the power rule to move this 2 in. So it would be 8 squared, it would be 64. So we have log of 99, 64, divided by log 99 of 4. So again, with the change in base formula, we can say that's the same thing as log 4 of 64. 4 to the third power is 64. Condense log 55y plus 5 log 55z minus log 55 of x. So we can multiply these use the power rule, and then divide this one out. So the first step again is always going to be the power rule for these condensing problems. So we have log 55 of y plus log 55 of z to the 5th power minus log 55 of x. So let's multiply and divide. So we have log 55 of y z to the 5th power all over x. And this would be our simplified expression, our condensed expression. Number 17, we want to condense this one. M log of 7 minus n log of 7. They have the same base. Let's use the power rule, rewrite it. We have log 7 to the m minus log 7 to the nth power. So we are going to divide these two arguments since we're subtracting the logs, and they have the same base. So we have log of 7 to the m divided by 7 to the n. We can use our exponent property, our quotient, subtracting exponents, to further simplify this. So we have log of 7 to the m minus n power. This next one, we have a lot of natural logs again that we could change it to ones. If ln of e to the 7th power plus ln e to the negative 9th plus ln e to the 4th power equals x, what is x? Well, this is just 1, this is just 1, and this is just 1. Using your power rule, these exponents become regular numbers. So you would just combine these three numbers together. X equals 2. Number 19, condense p log of 100 plus p log of 1000. Well, the base of the common log is 10. 10 to the 2nd power is 100. And 10 to the 3rd power is 1000. So we can replace log of 100 by 2. So it would just be 2p. And then we can replace log 1000 as 3. So it would be 3p. 2p plus 3p would be 5p. And that would be your simplified condensed expression. Number 20, 4 ln 2 minus 2 ln 4 equals, well, we can use our power rule to rewrite these. So we have ln of 2 to the 4th power minus ln of 4 to the 2nd power. We have ln of 16 minus ln of 16. Well, that's just 0. Expand. Log of x to the 4th, y to the negative 2nd. So now we're going to be doing the opposite for each of these. So instead of starting on the left side of these properties, we're going to be starting on the right side of these properties. Remember, the bases still have to be the same when you're rewriting this. So we're multiplying these two bases together, so we can rewrite it as log x to the 4th plus log y to the negative 2nd. We can use our power rule to move these exponents back to the front. So we have 4 log x minus 2 log y. And that would be our expanded expression. Okay, the next one, ln 10e to the 5th power. So we can rewrite that as ln 10 plus ln of e to the 5th. We can use our power rule to move that 5 to the front. So we have ln of 10 plus 5 ln of e. Now, even though this is expanded, if we have something like ln e log of 10, anything like that, we'll want to go ahead and reduce that anyway. So this will just be 1. So we're left with ln 10 plus 5. 24. Expand log 3 of 27 divided by 17. We want to use the subtracting logarithms property. So we're going to have log 3 of 27 minus log 3 of 17. This is another one that you could easily simplify from here. So log 3 of 27 is 3 because 3 to the third power is 27. So our expanded expression would be 3 minus log 3 of 17. Number 25, expand ln of r to the 7th times e to the negative 7th. So we can write that out as ln of r to the 7th plus ln of e to the negative 7th. Use your power rule. So we have 7 ln of r minus 7 ln of e. Well, ln of e is just 1, so we don't have to write that part, since we're just multiplied by 1. This would be your expanded expression. 26. Expand log 4 of 8h squared divided by f to the 5th power g to the 3rd power. So we're dividing this together, so the first thing we would do is subtract 2 logarithms. So we have log 4 of 8h squared minus log 4 of f to the 5th power g to the 3rd power. From there we can further expand it by turning this into 2 logs added together and this term into 2 logs added together. So we have log 4 of 8 plus log h squared, or log 4 of h squared, and then minus parentheses log of 4 f to the 5th plus log 4 g to the 3rd. The reason why I put parentheses right here is because both of these are going to be subtracted. So then we have log 4 of 8 plus 2 log 4 of h, we just use power rule, minus 5 log 4 of f minus 3 log 4 of g. This would be our expanded expression. Next we have expand log 9 of 81 to the tth power divided by 9 to the bth power. So we're dividing these, so we're going to have log 9 of 81t minus log 9 of 9 to the b. Okay, so we can use our power rule to move these exponents to the front. We have t log 9 of 81 minus b log 9 of 9. 9 to the second power is 81. 9 to the first power is 9. So we have 2t minus 1b. In this case, even though we expanded it, it looks more simplified. We'll skip number 28. 29 says log 36 of 216 equals something. So remember, it's the same thing as 36 to some power equals 216. Notice that these are multi-powered bases. 36 is a perfect square. It's 6 squared. 216 is also a multi-powered base. It's really 6 to the 3rd power. So we have 6 to 2x equals 6 to the third power. Log 6 both sides. And we could do that from our definition of a logarithm. If you take the log of that base on both sides, it just gives you what's left in the exponent. So we're left with 2x equals 3, divide by 2. So log 36 of 216 equals 3/2. Number 30, expand ln of 8 over e to the third power. We can subtract two natural logs. 8 minus ln of e to the third. Use our power rule. We have ln of 8 minus 3 ln of e. Remember, ln of e is 1 because e to the first power is e. It's just 1. So we're left with ln of 8 minus 3. Number 31, evaluate. Log 25 of 125. It's a lot like number 29. So we could rewrite that. We'll say that this equals y. So that's the same thing as saying 25 to some y power equals 125. These are both multi-powered bases. 25 is a perfect square. 125 is a perfect cube. 25 is the same thing as 5 times 5. 125 is the same thing as 5 times 5 times 5. So we have 5 to 2y equals 5 to the third power. We'll log base 5 both sides to get rid of our bases. We're left with 2y equals 3. Divide by 2, and then y equals 3/2, just like on number 29. On number 32, expand log 100t to the third power divided by v squared t to the fourth. We can rewrite that as log 100t to the third power minus log v squared t to the fourth. We can further expand this by saying log 100 plus 3 log of t. And we just move that 3 to the front from our power rule after that. And then we have minus 2 log of v minus 4 log of t. Log of 100 is the same thing as 2. So our expanded expression would be 2 plus 3. And also we would combine these two terms. So we have 2 minus log of t minus 2 log of v. And then for our last one in this video, we have expand log d to the negative 6 f to the 24th power. So we'll change this into adding two logs together. Log d to the negative 6 plus log f to the 24th. We'll use our power rule to bring these exponents to the front. And then we have negative 6 log of d plus 24 log of f. I hope these examples helped you further practice your skills in condensing and expanding logarithmic expressions.